Hello guys, I have not posted in a while, so I just found this I worked on within the weekend, and then I just you know thought I can make a video and then add to my portfolio. Right, so I needed a frequency detector for a project. Right, I needed to get the frequency of an audio because I was taking it from a mobile app from a phone. So the system had a phone connected to it. So this jack connects to a phone, and then this ESP32 will just sample the audio and then give you the frequency. It worked very well. I will post a video of me testing it. So there are a number of videos on YouTube where people just take frequencies and then they vary them. So I used that to test and it worked perfectly. Let me open it up. When I started, I just connected the pin because we had a one ground and one pin. So if you don't know, jack pins have audio pins have three cables, three sections. When there are four, it means it has a mic. When there are three, it means that there is no mic. So the biggest one, the largest one, is mostly divided into two. Not mostly, sometimes. When there is a mic, it's divided into two. When there is no mic, it's just together as one. The first section is either the right or the left, and then the second is also either a right or a left. Then this becomes a ground in my case because there is no microphone. It becomes a ground. And so you take the ground, and I took the the signal pin, the right or the left. I don't know which ear I used, but it's either a right or a left. I took it to an audio pin. I think I used 32 or 34. I don't really know which pin I used. It's either 32 or 34. Yep, it's this way. Ground, ground. Yep. So it's either 32 or 34. I think I used. I didn't use any of those. Yes, I did. I used pin 34. That was my because it's an ADC pin. It has a lot of digital converter on it. And then there's a little circuit in here because this guy was giving a signal that was so rough and it was so quiet and so sad, so you couldn't even detect it. So we needed, the way that AC is, alternating. The pi is only sensitive to DC, right? Zero plus, right, greater than zero. But this signal that's going to come is going to be sinusoidal. It will have positives, right? It can go up and it can come down. It can come down. That will be negatives, like -1, -2. So the ESP cannot measure in the negative range. So we had to block off that signal and just take the positive. So this capacitor does that. It's a 10 microfarad capacitor. And then there's a voltage divider here. What did I use this voltage divider for? So the signal is too small at a point. It will be too small to be detected by the ESP32. And so we raise it up to a base of like out of 3.3, we raise it up to like 1.5 or 1.2, 1.15. Right, so I did the voltage divider here. It divides 3 volts. The ESP32 has 3 volts and the ground. There is 3 volts between the ground and the 3 volts pin. So I divided that into two by two 10K resistors. And then that was connected to my signal pin. So it means even with no signal, my signal pin has almost half of the current, half of the voltage there. That means that makes our audio, kind of like build upon what is already there, right? That makes the signal more clear. So that's what I do during the weekend. I would post a video of it working. I will also post a video. I also post the code. I also post the circuit diagram. This is a 3D printed piece I printed for it. It has a cover, and yeah, basically that's it.